Hello, my name is Andrew Arma, and this is my Lab 4 for Physics 2. The purpose of this lab is to investigate the properties of circuits and their basic components. This is accomplished by building a basic circuit and then seeing how alterations to it affect its properties, specifically how resistors operate in series and in parallel, and the effect of capacitors. Circuits work by having a constant electric field act across a wire. The electric field is generated by a battery, which has a voltage difference between its end. This potential difference is usually created by chemical means. The electric field accelerates electrons within the conductive wire, which creates electricity, which can be used to power a load. Since the electric field is constant at any point in the circuit, it's easy to calculate the potential difference between any 2 points in the circuit. The current of any circuit can be found by dividing the electromotive force or voltage of the battery by a total resistance, according to Ohm's law. However, in cases in which the circuit splits, the current is divided equally among the branches of the circuit. The experiment consists of building various circuits using an online tool and then measuring the current and potential difference at various points in the circuit. The first circuit was basic, with just 2 resistors and 2 batteries. As expected, the current at both ammeters is identical because the circuit only has one path for electricity to flow. The ammeter says the same thing regardless of which direction the current flows through it. When one of the ammeters is replaced with a voltmeter, there is a potential difference of minus 3 volts, and the current is now 0. This is because the circuit was broken. When the potential difference is measured at each part of the circuit, the value is 0 at every point except for the batteries and between the resistors. The potential difference between both resistors is equivalent to the potential difference of the battery. This is because the wires have so low resistance that they can be treated as not there. The ammeter reading doesn't change when the voltmeter is attached because the voltmeter doesn't affect the resistance, so the current is constant. For the next part, we investigate an RC circuit. These are circuits that contain a resistor and a capacitor. These are interesting because their properties vary with time, unlike a normal circuit. As current flows through the capacitor, the brightness of the bulb decreases as charge is saturated. Eventually, there is no current. When the capacitor is directly connected to the bulb with no battery in the circuit, current flows until the capacitor is discharged. It takes around 5 seconds to charge and 3 seconds to discharge a 10 ohm bulb, and it takes 10 seconds to charge and 8 seconds to discharge the 20 ohm bulb. This is because a higher ohm bulb means less current flowing, which charges and discharges the capacitor more slowly. The RC constant of a circuit can be calculated by taking the slope of the natural logarithm of the current voltage of the circuit divided by the original voltage of the circuit, or the battery. The RC value should be equal to the resistance times the capacitance, which is 6, which means it should take around 6 seconds for the current to cease to flow through the circuit. If this lab were done in real life, the current values would be slightly different because an ammeter would disrupt the current slightly and add a minuscule amount of resistance. If the experiment were performed with no resistor, the capacitor would charge almost instantaneously. The actual time would be slightly different from any prediction because real wires have a very small amount of resistance that would affect the RC value. Thank you for your time.